Assalamualaikum students. Today's our topic is Introduction to the Set and Operation on Sets. Set is well-defined collection of distinct objects. Objects are also called elements, members. These are the objects or members or elements of the set. Set denote with the capital letter and set notation is curly bracket. We use curly bracket when we place a set. And well-defined mean thing is belongs to this set or not belongs to this set. We say I'm asking one, it is belongs to this set. You said yes. If I call 2 belongs to this set, you can also say yes. If I say 6 belongs to this set, then you know 6 is not belongs to this set. 4 is not belongs to this set. 8 is not belongs to this set. 10 is not belongs to this set. Well-defined means you properly know which things belongs to these sets or not belongs to this set. Na means number of elements. When we talk about number of elements, you have to calculate objects 1, 2, 3, 4. These are 4 numbers. 1 object, 2 object, 3 object, 4 objects. We have 4 objects. Number of objects is 4. 3. When we have to write 3 belongs to A, this is the sign of belong. So this is the sign of belong. 3 belongs to A. 7 not belongs to A. When we write this sign, it means this is belongs to the set. If we write this sign, it becomes not belongs to this set. You can also write shirt, hat, t-shirt belongs to the set. If you also write ABC set, this is empty set, this is also sets, this is also sets, different types of sets. Set is well-defined distinct objects. Well-defined is also know this is belongs to the set or not belongs to the set. Distinct means different to the other. You can see if you have green, blue, orange, you have different numbers, this is the set. If you have 1, 2, 3, 4, this is the set, this is well defined. You have D set, but you can see these are the 2 numbers placing here 1, 1, 2, 3, 4, 5. This is the set, but the proper way of writing it become 1, 2, 3, 4 and 5. This is the proper way of writing the set. This is also the set collection, but this is the collection of good student. You do not know who is belongs to this set or not belongs to this set. So this is not a set. E is not a set. E is not a set. But B is different and know easily which is belongs to this or not belongs to that. So this is the set, C is the set, D is the set, but E is not a set. Empty set is also a set. This is how we write empty set. Empty set, we know this is well defined because we know nothing is belongs to this set, or different because it have distinct objects. When we do not have objects, then it's also distinct objects. Set have 3 types: descriptive, set builder or rule form, roster form or tabular form. Descriptive, in descriptive form we can write in this form in sentences like A is the set of all vowels in the English alphabet, or B is the set of odd natural number less than or equals to 11. C is the set all square numbers less than 26. P is the set all letters in the word set theory. Q is the set of all prime numbers between 10 and 20. When we write set in the sentence type, then it is called descriptive form. You can see set is set of all natural numbers, set of all prime number less than 100, set of all letters in English alphabet. Set builder form or rule form. When we have set builder form, it denotes notation describing a set by indicating the property, like X is the letter in the word dictionary. We write it as A is the set of all X letter in the word dictionary. This line is called such that, or we can, these 2 points are also known as such that. For example, A such that X belongs to the natural number. X is the natural numbers. P equals to X such that X is the prime number less than 100. You can write X and describe X here. X is the letter in the word dictionary. Or you can say is the set, A is the set of all X such that X is the letter in the word dictionary. A is the set of X such that X is the letter in English alphabet. X is English alphabetic set. Or roster form or tabular form. Listing the all elements inside a pair bracket is called roster. Normally we can write in this form. A is the set of even natural number less than 11. In roster form, 2, 4, 6, 8, 10. Natural number is even natural number is 2, 4, 8, 10. Then integers less than minus 1 is less than or equals to X less than 5. Then you can write here, bracket will be curly. You can write curly brackets. You can write here curly brackets, or otherwise it is not a set. When we write curly bracket, it is the set, otherwise it is not a set. So in roster form we can write this. Descriptive form, set of all real numbers, set of all vowels in English alphabet, or positive integers less than 15 or equals to 10. In set builder form, X is vowel. This is put in the brackets. This is right in the sentence. This is right in brackets, and describe first of all X. X will not X. Then put 2 dots. Then we describe the value of X. You can also see putting X in the bracket, then describe X in the here. Bracket will be curly. Always you use in set is curly bracket. Roster form is this. You can see direct those value we can put. In this we can only write the values, then we write in this form, then we have this form. Set of real numbers. Set of natural number is 1, 2, 3, 4, 5 and so on. This is 10 to infinity. You can put here close bracket, starting curly bracket and close curly bracket. Set of whole numbers is 0, 1, 2, 3, 4, 5, 6, 7 and so on. Set of integers numbers -3, -2, -1, 0, 1, 2, 3, 4 and so on. Set of even numbers 2, 3, 4, 5, 6, 7, 8 and so on. Odd numbers 1, 3, 5, 7 and so on. Prime numbers 2, 3, 5, 7, 11, 13, and so on. Rational numbers. Rational numbers is in the form of p over q. Q does not equals to 0. You can also write 2 over 3, 5 over 2, 9 over 7. Our denominator never becomes 0. Set of irrational number. Set x is not rational number. Set of real number is union of rational number and irrational number. Set of complex number is this. Type of set: null set, singleton set, finite sets, infinite set, equivalent set, equal set, subset, proper set, improper set, universal set, power set. Null set or empty set. A set which does not have any element. You can write here properly who does not have any element. Empty set you can write with curly bracket or write like this. When you put this form, this is not empty set because here you can have an element. You have to write curly brackets with empty space or write like this, not like this and this. This has one single element. This is not empty set. This is singleton set which has one element like this. You can put 1 to anything. Then we have finite set. In finite set we have countable numbers of members. Finite set are also known as countable set. They are counted. The process will run out of the element to the list if the element of this list have a finite number of members like 0, 3, 6, 9, so on to 99. You can calculate these numbers. A is integer 1 less than a less than 10. It starts from 2, 3, 4, 5, 6, 7, 8, 9. Now you have to calculate 2, 3, 4, 5, 6, 7, 8, 9. 8 numbers. A is the set of all English alphabet. You have to count it. Set of months in a year. You can count it. Those sets which are countable, then it is called finite. Infinite, in which you do not know the ending value. X is a triangle. N is the set of natural number and we do not know which is the ending value. It will start with natural value 1, 2, but we do not know the ending value, so it becomes this. Set of fractions. The number of element is finite. Finite set A is denoted this. Number of element of finite or infinite, both you can write normally here. You can write n of A. You can write this thing in finite set or also write this in finite set. In finite set or in finite set. Now example of this is A is the set of positive integer less than 12. Then you can write this, count this element, then it is 11. Set of numbers which is multiply with 3. then you can write this. This is infinite set. This is finite set. This is infinite set. D is the set of integers x defined by -3 less than x less than 6. Then this is D value. So this is finite set. If Q is the set of letters in the word hello, then this is element is 4. L is 2 times, so it is considered as 1 time. So this is finite. Equivalent set. Two sets are equivalent if these sets have the equal number of elements, like A and B. A, B are equivalent set, but B and C, these have 3 elements and this have 4 elements, so B and C are not equivalent set. But you can calculate C have 4 elements, 1, 2, 3, 4, and D also have 1, 2, 3, 4 elements. Then C and D are equivalent set, but A and D are not equivalent. B and D are not equivalent. Your number of elements will be same, then it is called equivalent set, like blue, red, green, and B is 2, 5, 8, then this is equivalent set. C equals to shirt, sweater, jacket. This apple, banana, orange. Then C and D is equivalent set. X is smiley, sad, and Y is 1, 3. This is equivalent set. But A equals to 9, 12, 16, and B equals to A and 12. This is not equivalent set because this has 3 elements and B have 2 elements. So this is equivalent set or not equivalent set. Equal set. In equal set you have members will be the same. You have A equals to P, Q, R, S. B equals to P, S, R, Q. Number of order will be changed, but values will be the same. You can see here P, P, Q, Q, R, R, S, S. Then it becomes equal. A equals to B. And you can also say A is equivalent to B cube because A have 4 members and B also have 4 members. A is equals to B. A equals to green, blue, red, black. B equals to 1, 2, 3, 4. Then you can see this is equivalent set but not equal set because these are the number of colors, these are the countings numbers. So this is not equal set, but it is equivalent set. Example number 3. 2, 5, 7, 9. B equals to 7, 9, 5, 2. You can see values will be the same. 2, 2, 5, 5, 7, 7, 9, 9. This is equivalent set and equal set. We have example number 4. A equals to ABCD and Q equals to DCAB. This is equivalent set or equal set. Subset. Subset is the set which we have one element is less than from the set or equal to the set. Like A equals to this, diamond, heart, spade, and this, but B equals to this. Then A is the subset of B, but B is not the set of A because we have triangle is not in the A set. B have triangle which is not belongs in the A. So A is the subset of B, but B is not the subset of A. B contain element not in A. So A is proper subset of B. Or I1 is interval 0, 2 and I2 is interval 0, 1. You can see these are 0 to 1, 0, 1, 2, but I2 is 0 to 1. It take this value, so this is greater in this, so I2 is subset of I1. The definition of subset allows possibility that first set is same as or equal to second set, but its proper set must be smaller than the second set. Find the subset, use 2n. When we find subset, if we have set like b equals to 1, 2, 3, 4, we have to find subset of this. We write 2n. N is the number of element. Put number of element above 2, it become 4. It is equals to 16. This set has 16 subsets. Find the proper subsets. Proper subsets are those in which we have less than, like this. This is proper subset. We have b is greater number of elements and a is less. In B we have 5 elements and in A we have 4 elements. Then B is proper subset. A is proper subset of B. A is proper subset of B. So we have to find then 2n minus A. A subset contain all elements of the original set is called improper subset. Basically, improper set includes the null set and the original set itself. When we find, then you can see two sets are always right, which is null set or its original set. This is called improper set, and improper subset will be right like this. A power set is set which have all subset of set. You have two sets like x and y. In x you have E, A, R. In y you have E, A, R, D. In x you have 3 elements. In y you have 4 elements. So x is subset of y. You can write like this. You can see like this. A is subset of B. You can write like this. A have elements 1, 2 and 4. You have 3 elements. But in B you have 5 elements. 1, 2, 4, 3, 5. You have 5 elements. So A is the subset of B. You can write like this. A is subset of B. 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 B is subset of C. Or you can see A is subset of C. Find the subset of X. When you have X, this set, then you have to find how many subset they have. You can write 2 and count this members 1, 2, 3, 4, 5. Then it becomes 32. So it becomes 32. You have to know null set and set itself also right. Then you have to write one element 2, then put second, put third, 4, 5, 10. Single you can write elements this. Then you put first, second, first, third, first, fourth, first, fifth. Then you can write second, and third, second, fourth, second, fifth. Then you can write third, fourth, third, fifth. Then you write fourth, fifth. Then you write 3 elements. First 2, 3. 2, 4, 6. Then you write 2, 4, 8. Then you write 2, 4, 10. You can see 2, 4, 10. Then you write 2, 6, 8, 2, 6, 10. Like this. Then you can write 2, 8, 10. Then, because we have to complete 3 elements, then you can stop taking this number. You can take 4, 6, 8, 4, 6, 10, 4, 8, 10, like this. Then stop taking this number, starts with 6, 6, 8, 10. Your counting will be closed. With 3 elements, now you have to take 4 elements. 2, 4, 6, 8, 2, 4, 6, 10, 2, 4, 8, 10, 2, 6, 8, 10, 4, 6, 8, 10, and last is same. Now you have to find this proper set is these number, empty set to this 4n. Improper subset is which is equals to the set. So, finding subset of x equals to 1, 2. You have 2 elements, put n equals to 2, which is equals to 4. Firstly, you write empty set and set itself, then putting one member separately, then write second element separately. You have 3 elements, you have to solve like this. Universal. In this set you have all members you can write. Because we have universe, we have everything in this. You can describe how we have each number we consider in universal set. You can see these 2 examples. If we write numbers, these are also belongs to this square shape, rectangular shape, showing that you can have A set, B set, and these element which is not belongs to A, B. In also you can see these universals that have A set and B set. Operation on set. Union, intersection, complement, difference, Cartesian product, disjoint, overlapping, Venn diagram. Union set. 2 sets contain all elements in either set belongs to one set or belongs to both sets. Like normally you have example set A equals to 1, 2, 3, 4, 5, 6 and B equals to A, B, C, D, E, F. Then you are taking union of A, union B. Then you write both sets element 1, 2, 3, 4, 5, 6, A, B, C, D, E, F, G. Find the union of this set A, x equals to A, B, C and y equals to A, B, C, D, E. Union of this you can write when you have in both, you can write it one time A, B, C, D, E. Find union between G equals to 2, 4, 6, 4, 6, H equals to 0, 1, 2, 3. Then G union H equals to 0, 1, 2, 3, 4, 5. So you have to practice these questions now. Then you have to know how to solve union. Now you are taking intersection on 2 set. It also containing both set. When you have same numbers in both sets, then you write in the intersection set. Like A is this and B equals to this. These are not the same elements. One is not equals to A or nothing. These are the alphabet and this is the numbers. So this is not similar. So intersection will be empty set. X equals to ABC and Y equals to ABCD, but we have similar in ABC, so intersection is ABC. Intersection between G equals to 0, 2, 4, 6 and H equal to 0, 1, 2, 3. Then intersection will be 0 and 2. A equals to 1, 2, 3, 4 and B equals to 2, 4, 6 and intersection will be 2 and 4. You have example like green, red, orange and B is red. Red is similar, so answer intersection will be red. H is 2, 4, 6 and F equals to 1, 3, 5. Then both our numbers are different, so intersection will be empty set. You have to practice these questions. Now we have complement. In complement, A contains everything that is not in set other set. Complement of will be noticed in like this, or like this. This notation is commonly used. Complement of A. Find the complement of set A. A is 0, 1, 2, 3, 4, 5, 6, 7. You have universal set. You find the difference between universal set minus A. This is the complement of A. So A is this and U is this. U minus A equals to, you have member in U but not in this remaining elements. You have to see 0 we have in A, 1 is in A, 2 in A, 3, 4, 5, 6, 7. These numbers belongs to A. These number will be cancelled. 8, 9, 10. These will be right in this. Find the complement of B. B is 0, 2, 4, 6. You have to see universal set. You have to find complement mean U minus A. Then you see universal set have 0 to 10. So you have to cut these number which is belongs to B. 0 will be cut, 2 will be cut, 4 will be cut, 6 will be cut. 6 will be cut. You can write 1, 3, 5, 7, 8, 9, 10. This is the complement of B. You have to find this question. You find difference between difference U minus A. Then solve this. Difference between two sets. Similarly, in complement you have to taking difference between universal set and with set. Here we have two sets. Find the difference. When we write here, we taking the element of this set, not this set. You can see A is 1, 2, 3, 4, 5, 6 and B is 5, 6, 7, 8, 9. A minus B, you can see these elements. You have 5 in B, so it will be cut. 6 in B, it will be cut. Only 1, 2, 3, 4. Which element not belongs to B? This is the difference between two sets. Then you have write B minus A. Then you see the element of these. B belongs to A. 5 belongs to A. 6 belongs to A. So your answer B minus A is 7, 8, 9. Find the difference. C equals to 5, 6 and D equals to 5, 6, 7, 8, 9. You can see 5 belongs to C minus A, then 5 belongs to D and 6 belongs to D. So our C minus D is empty set. When we write D minus A, you can see 5 belongs to C, 6 belongs to C, but 7, 8 is not belongs to C. So our answer is 7, 8, 9. Find the difference between x minus y. You can see x have 1, 3, 5 and y is 5, 6, 8, 9. 5 will be cancelled because y belongs to y have 5. So x minus y is 1, 3. When you have y minus x, you have 5 in x. So answer will be 6, 8, 9. Cartesian product. In Cartesian product, x equals to 1, 3, 5 and y equals to 5, 6, 8. Cartesian product, you can write 1 with first element of y, 1 with second element of y, 1 with third element of y. Writing style is small bracket 1, first element of x, second element of y. First element of x, second element of y. First element of x, second element of y. First element of x, third element of y. Then write second element of x, first element of y. Second element of x, second element of y. First element of x, third element of y. First element of x, first element of y. Third element of x, first element of y. Third element of x, second element of y. Third element of x, third element of y. Similarly, we have to solve y cross x. Then you take first element of y, then take first element of x. First element of y, then take second element of x. First element of y, third element of x. First element of y, then take first element of x. Second element of y, second element of x. Second element of y, third element of x. Then take third element of y, first element of x. Third element of y, take second element of x. Take third element of y, write third element of x. Then you also can do x cross x or y cross y in similar pattern. Disjoint set. If the intersection of two set is empty, then this is said to be disjoint set. Is odd numbers. Intersection of two S1 is set of odd numbers, odd natural numbers, and S2 is even natural numbers. Then this is disjoint set. When intersection of two sets is empty, then it is called disjoint set. Just like set of art student, set of science student. These are different students, so this is disjoint set. Overlapping set. When intersection of two sets will be non-empty, then it is neither subset of other. This is overlapping, like L is 2, 3, 4, 5, 6, N is 5, 6, 7, 8, 9, 10. These are overlapping elements. Property of difference of set. A minus bracket B intersection C equals to A minus B union A minus C. A minus bracket B union C equals to A minus B intersection A minus C. Solve example, find difference of set using Venn diagram. You can also use previous method through sets, or you also know Venn diagram sets. A is this, B is this, C is this, using part A. According to the condition, A is this, B equals to this, C equals to this. You have to we solved this question before with previous method, then we solve with Venn diagram. You have to take left hand right Then firstly solve this B intersection C. When we take B intersection C, this is this intersection answer is empty. Then take difference with this A minus intersection C, this is empty, so difference of A minus A intersect C equals to A set. Take right side, then take first this, then solve this, then take union between this, and our answer will be this. See, you can see both values are same, so it satisfies the property. Now you have to solve second part, Venn diagram. In this diagram we solve questions or denote set in rectangular form. Relation between sets in rectangular form or circles with label like this. B is the set of even numbers 16, 18, 20, 22, 24. These are the natural even numbers between 15 to 25. This is labeled. Between means 15 and 25 does not belong, and this is circle or oval. Label P. P is the element. Put P the element in P. You can write this Venn diagram of R. R is Monday, Tuesday, Wednesday. You can. This is the universal set. This is the R set. R set writing outside, or you can write here. So Monday, Tuesday, Wednesday, putting the element of sets. U equals to 1, 2, 3, 4, and A equals to 1, 2, and B equals to 2, 3. A equals to 1, 2, this is A, and B equals to 2, 3, and U equals to 1, 2, 3, 4. You can also say this. This is union form. A union B. A will be 1, 2, 3. Okay, or A is this part and B is this part, and this is union. This is intersection A intersect B, and answer is 2. Label your answer, colored your answer. You can see 2 is colored, so A intersection B is this. You can see all the things are colored, so A union B. Here we operate this because here we have A member and also B member. You have to reach before union. In union you can write all element of both sets, but in intersection you have similar element, then you write common element of the two sets. Now you have to say this is 3, 4, which is complement of A, and see this A minus B. So this is different set of two sets, and this is also different. This is A minus B, but this is B minus A. Here you can see in 3 sets. This is A set, this is B set, this is orange, this is A set, pink, this is B set, blue is C set. This portion here you can see this portion. In this portion you have intersection between A, B, C. These elements, like I write 3, this belongs to A, this belongs to B, this belongs to C, but in this portion I write 2. This portion denotes 2 belongs to B, 2 belongs to C, but in this portion I know my drawing is not well, but you have to understand these points. I write 0. 0 belongs to B, 0 belongs to A. Here you can see I write 4. It belongs to A, it belongs to C. Only this portion is, in this portion A, B, C, 3 sets are combining. You have similar pattern. You can understand X, Y, Z. Here you have X complement Y, Z. Here we have Y, X complement Y complement Z. Here we have X, Z, Y complement. Similarly, this is the complement, means absence of that thing. Sample set will be denoted like this: intersection, union, proper set, subset, not proper set, superset, belongs to, not belongs to. Operation on 3 sets, you can see this. You have to apply these things. We are taking 3 sets: A union bracket B union C. Then take firstly B union C, which is equals to 3, 4, 5, 6, 7, 8. Then take A union B union C. This is this. Now we have A union B union C. You have to solve this, then take this. Last answer is same. This and this value is same. It will be changed when we take different elements, because we have union here, so our and set value is same, so our answer will be the same. Now we have set this and we have to solve this. Then firstly solve B union C, answer will be this. Then take intersection with A, then answer will be this. 4 and 5 do yourself, and 6 A intersection C union B intersection C. A intersection C equals to 3. Secondly B intersection C will be this. Then take union between them. It will be the answer this. 7, 8, 9 do yourself. You have some properties, some formulas. You have to know these formulas. Remember these properties. Computative property of union. In this you take union this and this. We are using these sets. Our answer will be satisfied. Then you have to want to change these set elements and try on this. It's a better opportunity to know how it works. A intersect B equals to B intersect C. Then taking intersect, answer will be the same. Associative law of union. Then taking this, left side is this, right side answer will be the same. Using associative property of intersection, firstly solve A B intersect C, which is empty. Then take intersection between A intersect B union C, B intersect C, which is empty set. Then take right side. Firstly solve B intersect A intersect B, which is equals to 2. Then take A intersect B intersect C. Then left side equals to right side. Distributive law. Then firstly take B intersection C, then take A union B intersection C. Here B union C, then A union C, then taking intersection between them, and answer will be the same. A equals to 1, 2, 3, B equals to 2, 3, C equals to 5. You will solve and answer will be the same. De Morgan's law. In this you have to know these properties. u equals to this, a equals to this, and b equals to this. A union b whole complement equal to a complement intersect b complement. Then you have to solve this, and taking union, then take complement of this. This is the answer. Taking complement of a, taking complement of b, then intersect, answer will be this. De Morgan's law part 8. De Morgan's law part will be second, but in properties we have part 8. Solve these properties with this method, with these sets. Then you have to solve these questions. Thank you. If you have any question, you can ask me here.